Okay, and the first thing that I want us to do is I want us to navigate to the tab that says R, and let's go ahead and click on Getting Started with R. Folks, and this has been my experience throughout the years. I picked up languages very easily after I picked up the first. So I struggled figuring out basically MATLAB. The moment that I started with Fortran, that was relatively simple but not very powerful. And then I focused on MATLAB. I picked up MATLAB after like 3 years of working with it. And then somebody said, you know, statistics, you can do that with R. Picked it up in a semester. Then they said, oh, you know what, Python is very interesting. Picked it up in a couple of weeks. So it's not, it's the first one that will give you trouble. Like, how do you do this thing? After you get that one down, every other language is very straightforward and very, very fast. Also, a big hurdle if you're starting to learn something on your own that has to do with computers, how to get the damn thing to work in the beginning. We'll make sure we can do that now. All right, so we'll install R and RStudio in your computers. So go ahead and click on the first link that you see here. As I said, R is a language. Okay, so it's not just a statistical package like Stata or SAS. It's a whole language. You can program in it. And to download R, you can go up here and click on a download R link, and it will take you here to mirrors. R is not small. It's not that large, but it's not small. Therefore, these folks over there are offering you some places for you to download it. And they say, let's spread it out to the world. Choose any mirror you want. It doesn't matter. You're downloading it, for example, from Germany. It's the exact same R as you're downloading from California. Just choose any of these. I'm going to go ahead and choose something from USA. And you know what? I'm going to download the one from Kansas because I have a friend over there. So it's going to take you somewhere and probably looks like that. They basically replicate in various places so that they don't create a lot of traffic in just one place. If you have a Mac, throw that away and buy a real computer. If you have Windows, click on the third link. Now, if you have a Mac, click on the second link. All right, so click the one that works for you. And if you have not installed R in the past, it says right there, install R for the first time. Click on that one, please. If you already have R in your computer, don't do anything. We'll update it with it. Actually, we don't even need to update it. You probably will prompt to do that earlier on. But if this is the first time that you install R, hit on that button, please, and wait a little bit for it. Those computers already have R, so you don't have to do that. But if you're installing it, it might take a little while. Let's see. You have R? I do. Yeah, go ahead. No, hold on. It doesn't take that much. It's like 80 megabytes. It's not small, but then it's not like 5,000 megabytes. 8 megabytes. So R is the language. It comes with the interpreter and all that stuff. Download. Downloading. That long. But you know, R on its own looks kind of primitive. It's just code, command prompt, you type stuff in it, it works. We're not computer savvy except for one or two of us. We would like some sort of graphic user interface. Just like JNP Pro did a lot of things with click and drag. You know, there is such a thing for R. That's probably why R is super popular, because of RStudio. So as we're waiting on R to download, let's navigate back into the original one. Wait, where's my Moodle? All right, Moodle. All right, let's go back to our course. And besides R, in the Getting Started one, there is another one that says RStudio. Let's click on that. Now, this is a little bit more involving. What is RStudio? It's just a graphic user interface that speeds up R. Okay? What we want is just this RStudio part. So click on that one. Whoops, there was a download button beneath, but you can find the download button here. And RStudio is a proprietary software, but they also have a free version. Click on the free version unless you want to pay $1,000 a year, which I don't think you should. All right, and it will take you to this. Either way, like if you click on download or if you navigate to the other one, you get greeted by that screen. You see that? Oh, you got it already. You see that? Click on free, it takes you to the right here, and you gotta choose the one that you want. What kind of windows do you have? Probably Windows 10. It looks like. Click on the first little link, and it's gonna say do zero. Save.
Yeah, cool.
Yep. The free version. There, we got Windows 10. That one. And it's downloading. Yep. Do you have RStudio in Art? Yeah. Yep. Do you have RStudio in Art? Yeah. Cool. Yeah, you put some fast buttons. Alright. And you got RStudio. Fantastic. Let's give everybody a moment. Now, R should have downloaded. Just need to click on the installer button. So go back to the other tab that installs R. Just click on install executable. And ask you, can I please install this in your computer? Say yes. And do the same thing with RStudio. I need to remember not to leave this spot because the mic is right here. So, who's downloading it, by the way? Okay, 1, 2. Did it ask you to run something for the RStudio? Actually, you should install RStudio after you install R. Yeah. Anyhow, it's going to be this big blue button that has RStudio on top of it. You can find it by typing RStudio. It's one word. Don't put it out. One word doesn't pop up. I'll put it up there, and then I'm just going to run around and see where you guys are at. And don't worry that yours doesn't look like this. I've done a bunch of stuff and all of them are kept. Save. 5. Boom. So this is how a clean RStudio should look like when you put it up. Still downloading. Alright, so as Frank Zaporo, my TA, says, R is the engine, RStudio is the back. You can't do with, you can't really do it without an engine. Actually, you can't even do it with a dashboard. I was never really proficient in R until RStudio came about. I'm like, oh, I totally do this. All right, so a couple of things about how RStudio looks like. Bottom left corner, that now is scaling up, covers the whole left corner. You see the console. That's basically where the commands are written and interpreted. You can use that to write commands in a one-by-one fashion. It's a glorified calculator, so if you go to the console right now and do 5 plus 3, go ahead and do that. Just type 5 plus 3 in the console and hit enter. 5 plus 3 and hit enter in the console, not in the screen, just in the console. Hit enter, see what happens. So if you go to the console and do 5 plus 3 and hit enter, actually, I I need to go to the console. 5 plus 3 and hit enter. It tells you that the answer is 8. Great. So R is a calculator. I mean, it's a lot more stuff than that, but it's definitely a calculator as well. Right, but the idea is not to do one command at a time. I don't think you can create programs like that easily. The idea is to string a bunch of commands one after the other and generate what we say a program. To do that, the best practice is to create a new script. Okay, follow along. Top left corner, right there. You see that little plus button? You can view your own screen. It's right underneath where it says file. There's a plus button and it gives you some options. What we want to create is a new script. So now the real state of our studio changed a little bit. And you have all this area right here where you can basically write your commands sequentially, one under the other. Okay? And then you save that as some sort of text document. As a matter of fact, it's just an R document. And you run all of them at the same time, a piece of it at the same time, and so on and so forth. That's the practice, folks. We never really use the console. We always write our commands in the script and we execute them instead of like running them one by one in the console. That's not very good. All right. So this area over here is where you put your various commands, and we'll see one in just a second. Top right corner, where it says global environment. Okay, do you see that in front of you? That's where all the variables, data points, matrices, and all that are going to pop up. It's very, very cool because you might be reading a data set. This will give you a quick way to view that data set. This will give you a quick way to view those labels. You can view the names of the variables and so on and so forth. So all that is going to be hidden up there. Okay. Bottom right corner. Bottom right corner has many, many tabs. The first one is titled Files. This tells you what sort of files you're looking at in the directory that you're working at the time. If you change your directory, it will tell you what files are in there. Good practice in coding. Put your data and your code in a new folder somewhere in your environment. So you're starting a new project. Great. Find where you want to save it. You want to put it in your homework, for example? No problem. Start a new folder that says blah, blah, blah. New folder, project 1 on this. And dump everything in it. Data, the codes, the results, all in one folder. Because R is a smart machine. You don't have to tell it where to find the data. You can just tell it, find it in the same folder that I keep my codes. For example, SAS cannot do that. So if you play your cards right in the beginning, things are going to be very, very simple with SAS. If you put everything in the same folder, it's going to work just fine. And they're also going to pop up down here. So you'll see what's in there. All right. The second tab is plots. Again, statistics, we created a lot of things like histograms, box plots, whatever. They show up here. Okay, for a quick preview. You can export those as images or PDFs using some simple clicks. We'll do an example or two from that. Next package, super important. Sorry, next tab, super important packages. Here we need to step back a little bit. So, why is R a much better tool to do statistics or basically data analytics than SAS? Well, here's the thing. R is free, and also all the code for developing R is available. Which means if you're super smart, you can take R and extend it to do something that you would like it to do. And then create what is called a package. A package is basically an extension of R that does a specific thing. better graphs, better analysis, or specific analysis. For example, you're doing something in biology, and you do that over and over and over again. You write a code, write a cute code that bypasses all that. Instead of just giving that code to somebody, you can make it into a package. And so other folks can just download your package and do exactly what you're doing just by pressing a couple of buttons. So R is, as we say, modular. It's got the core, and you can add stuff to it. And since it has such a big base, there are so many modules out there, there's so many packages out there that do practically anything. If you dreamt about something, oh, I wish it would be great if you can do this with R. Well, chances are you can do that with R, and somebody else has created the package for it. You just have to Google that package. This tab is going to be useful in a little bit. We're going to use it to install packages, enable packages, and update packages, right? Another cool feature about R is its amazing help. You can basically type anything you want, and there's a good explanation here, including examples. But we'll see that Googling examples in R is a breeze. Now, I think Alex will tell you here that Google anything you want in R. There are 5,000 answers to it, and good answers as well. Right? There's a Stack Overflow that everybody's using, CRAN, and
There's some confusing answers too.
sure, but especially if you're using Stack Overflow, just go with the top one that has a lot of pluses. Anyhow, so since it is free and open source, it has a huge community. People would like to help you, and somebody else has had that question in the past. Somebody else has answered that question. I have answered questions most of the times correctly. Finally, there's a viewer. We don't really need that right now. Let's talk about it later. So that's the real estate of RStudio. Okay? You can also see a couple of things about the history, what have you done in the past, and also which connections are open. These are kind of like extreme. All right. Any questions, any problems? We're going to be writing commands on the script, saving it, and running it. Okay? But in order for us to do that, we need examples. All right. Let me pull this one down, go back to our Moodle. Okay. So, if you want to know a little bit more about R, you can always check this YouTube video that basically just handheld you and tells you a little bit about R. Or, my advice, play around with it. Figure out something that you want to do in R, just go ahead and try to do it. Get your hands dirty. And I'm giving you some trinkets. So basically, I mean, this is what happens in practice, right? At some point in life, you're asked to do a task that requires writing a code. Great. You do that, and then you don't throw away the code. You keep it in there, and you just modify it next time you want to do something similar. So this is my collection of, as I say, R trinkets. Things that I have done in the past. You can have it. I also have the data sets attached to it, so they just work. Okay? Now, here's the difference. And this has happened to me. You do something this year, and you go like, oh, yeah, I get it. And you come back 3 weeks afterwards, and you look at the code like, that's probably Chinese. So, or you know, choose your favorite, Greek. I can't say Greek. The point is, when you create a code, put documentation on top of the code. So that's going to be one of the first tasks that I'm going to ask you to do. I'm going to be giving you codes, both in R and in SAS, sorry, both in R and in Python. And your task will be, okay, what does this line do? You put that next to it as a little comment, save the whole thing, come back 3 years down the road, the code is not going to be bad. It's still going to work. Might not be as efficient. Hey, a couple of things might have been updated, but it's still going to run. Okay? Right. So, if you click on this, I have all sorts of things here. Yeah, go ahead. And as you can see, I have a folder that I say check. All these codes work 100%, right? They have documentation attached to it. I have the data sets and whatnot. So if you want to create a box plot, click on this. That's how you can create a box plot. How can you create a data frame out of scratch? Play around with the basic distributions. Heck, you can even create a neural network with R. We're going to use Python, but if you really want to, there's one. How to create multiple graphs. You may have like 500 graphs you want to create at the same time. That's how you do it. Read various files. Create scatter plots. Do a t-test if you're doing statistics. Okay. All these things are there. But I got some other ones that the codes work, but I don't have enough documentation. So maybe you need to look into it a little bit more and try to muddle your way through. So here's one thing that you can do for the next week. Think of something that you want to do. Click on the R trinkets here and try to replicate it, or try to explain it, or try to figure out what the damn thing is doing over there, okay? So, I also have a couple of videos, and I promised to put more here explaining how to do ANOVA, how to do box plots, how to read data, how to do scatter plots. This is me talking over, I'll have the video for it, okay? And then I also have the code that goes with it, the data, and so on and so forth. All right, so you can follow along with those simple videos if you'd like. Simple scatter plots, for example, or whatever. All right? So, R trinkets. Download whatever you want to download, save it, copy. You got free range of this. Agreed? Every year, this one gets updated. I put more stuff. I get to do something cool, I get to do something new, I throw it in there. Every time I remember, I put documentation. And then it's easier for me to pick it up down the line. Has helped me, I don't know, best thing ever. I suggest start creating something like that too. You're going to be doing a very specific code to fix your own thing this year. Yeah, you might want to use that next year as well. All right, put some documentation, it just works. So R trinkets. Okay. Some basic links. If you click on R basic links, there is a link over there that talks about, generalities about R. If you click on the R intro, this will tell you more or less everything you need to know about R. It's, relatively involving. It's 105 pages. I don't suggest you read that. But if you want to, bedtime story for a kid, maybe, puts everybody to sleep. There's another one for RStudio. Again, tells you a little bit about RStudio. If you click on like about us, the products and whatnot, it tells you about it. This is the one that I like, basic R examples. Click on that. So these R examples will tell you how to filter data, read data, do some basic things about the functions. So you can do this approach. If you don't really want to do the R trinkets, you can check the R examples. And again, these are like, for example, how to filter data. And it's got the code, and it tells you what the code does, and it tells you how it does it. There is this book that I actually read from the beginning to the end. It's large, but it was funny. I couldn't put it down. R. Okay. It's actually very well written. It is funny. It covers practically everything. It's about it. But if you want quick stuff, our cookbook is the thing to do. For all the basic statistics, this online book, our cookbook, has everything you want using examples. For example, I want to do statistical analysis. Great. And I want to do a t-test. Great. This is how you do a t-test. Boom, boom, boom. Put the data set in there. Copy pasting everything totally works. So you can copy paste this one into your script, run it, and a data set is going to be created. You can copy paste this one into your script and a t-test runs. Got it? So when I was learning R, That's what I was using because I had a specific thing in mind. I wanted to do a specific analysis. I wanted to do basically graphs on it. Fantastic. I want to do a scatter plot. Great. This is how you do a scatter plot with examples and everything. All right. So the R cookbook is a fantastic thing to do if you have a specific task in mind. And I've never used this, the R for beginners, but when I asked around which one is the one that people use most of the times to teach R as a short, concise book, this one popped up. I mean, the library told me to use this one. So this is probably because it's small. It's R for beginners. If you want a textbook, and I think there's a printed version of that, that's the one that CRAN has out as the thing. CRAN is basically the repository for everything R. Okay, spend a little bit of time on those. Now, I was fortunate last semester to work with Frank Safor. Frank Safor is one of the graduate students here, and the guy is amazing. So he generated himself an introduction to R for the graduate students last semester. It was the first time that we were trying to teach 705 using R, and so he went all out with this. He's got, again, just like I said, snippets of code with explanations, how to install packages, how to run things, and it looks great, right? That was written in R. So the HTML file produced here was also written using an R code. Don't expect me to do that kind of crap. I mean, it's too much, man. He was doing knitter, and he was like super out of there, and he was doing his thing. Like, no, man, this is too much. Write a little script, put snippets of code right next to it, and that's fine. But you can make it as professional as this one. When you have inline codes that you can grab here and put, and they work, and so on and so forth. Okay? So I highly recommend reading his intro. It's fantastic. It's no more than, let's say, 20 pages, and it will get you there. Like, I don't know. It's great stuff. So, amazing introduction. And he has written also very good versions of this for other stuff that you can do in R. And I had him last semester post them on Moodle. I'm trying to get him to create a web page to put those up there because these are really gems. But, yeah, he's been slacking. Are you with me so far? All right. Of course, you're not going to learn R unless you get your hands dirty with it. All right, so if everybody has R and R Studio installed, I think this is a good time for us to check daily task of the day. All right, so click on this, please. Click on our daily task. And our first goal is to try to figure out how to merge multiple files into one. And then we will also try to figure out if you did homework number 1 correctly using an R script. All right, so click on the first, and it should take you to this Google Drive repository. Since we're going to be doing a new R code, create a folder somewhere in your computer, download everything from it. I need 1, 2, 3, 4, and the actual code. So download these 5 things and save it in a folder in your computer somewhere. Go ahead and do that. Download these 5 objects and save it. Make sure you create a new 1, 2, 3, 4, 5. So not the process. These are DBFs. Let's download those first. And also download this multireads.r. does this work? Okay, so notes. So download the 4 DBF files, database files, and the multi-reads. Hmm? What?
Now you don't have access.
Blah, blah. Okay, let's add you there real quick. Alright, so what's your LSU ID? F, N, O, V, V, E, E, 1. Thank you. Alright. Got it. Okay, so download the 5 files and the one that says multireads.r. Okay, so what are these things? These are measurements from a specific field by using one of those smart harvesters. So basically this is like a little combine that goes through the field and has a GPS attached to it, and every now and then it makes a measurement, right? So basically it knows where it is and it collects and it says, all right, I'm at this spot, makes a little rectangle and says, in the rectangle that's around this spot, I collected that much. Okay? And it also gives you information about the elevation where you're at, how much water went in that area, and so on and so forth. So it's got some information about a field on little plots on top of the field if you want to see it like that. Right. But it's a database file, a DBF. We kind of played with database files in the first part of the class, and we said Excel doesn't read that. Well, R reads them. Okay, so it's the same field over 3 years. The first year they had corn in there, then they split it, soybeans and wheat, and then they put corn again in 2017. Okay, and it's the exact same locations and so on and so forth. Right? So we want to do an analysis of that. How to put things together and so on and so forth. But if you try to do, okay, let me click on this. It says, how do you open this thing here? You just can't. I mean, Excel will not open this one. You can open it with JMP Pro and see how it looks like, but we'll have to connect and it's kind of takes a little bit of time. All right. Notice another thing here. The person that created this used the naming protocol that we had before. I mean, an adjustment of it. It was like the type and the year, followed by underscores. All of them DBFs. That's going to make our life easy. We're going to use a code to tell R to read all files that are DBF. Okay? How do we do that? Click on this multi-reads. This is the script that will allow us to do this. You should be greeted with that. probably opens up immediately in our studio. If not, it's just going to ask you how you're going to open Z. So go back, download everything, multi-reads. If it doesn't open it up immediately, you can just drag and drop it in there.
No, I'm just checking.
Do you remember it's the console?
Right. So you have to specify in the beginning. Just right click on the object and say always open file.
Oh, okay.
So you got to do that with the first one. Find the file itself out there. Download everything. Go to where you have those files. I open up the directory with these are in. Yeah, you have it. Always open file on this side. That probably gives you okay. Right click on it and you choose here what would be the default. Up and weak. There you go. There you go. Okay? So if it didn't open up with our studio and you wanted to open it up with R, right click on the thing and just say open it. There's a chance that you might not have our studio. But the next time it's still going to do that. So what do you see? Right click on multi-reads.r. Open on it. Say, oh, this one does not allow you to control. Still, it's not going to allow you. You can open up our studio and drag it in there. It works. You can open our studio and go to file and I'm open. If I go over here, okay. So, as we said, top left corner has the snippets of code that will do the thing. Over here it's empty because we haven't run anything. And there's nothing on the terminal. All right. As I said in the beginning, we need at the very, very first step to tell R which packages we're going to be using to do our thing. Prior to that, we have to make sure that those packages are installed. Okay? If you look at the top two lines, it says library easy packages. That is a package that helps you handle packages. It makes handling packages simpler. Hear me out. Since there are so many people writing code on it, sometimes they're creating conflicting code. Like, I create a code to create graphs, and you create a code to create graphs. So I make a package for graphs, and you make a package for graphs. And both of them are available. Now, if I'm trying to run both of them as a user, I've installed both packages, and I'm using a command here that basically sees the command there, the thing gets confused. So easy packages is a package that makes sure that all packages play along. And it's my favorite one. I always install it. I always have it there. Because that takes care of conflicts generated by multiple packages doing the same thing. Now, how do we install a package? Great. Remember this tab down here? Go to bottom right corner and go to the tab that says packages. There is a button over there that says install. Let's click on that. Are you all greeted with this? Okay, this one actually is a connection to the CRAN. That's where all packages are held. And if you start typing in the package you want, in this case, easy package, right? There's an autocomplete business there. Click on it. and then click install. So now our studio connects to crun, finds the package easy packages, downloads it, saves it into your computer. As long as you have an internet connection and the rights to install stuff in your computer, you should be just fine. Sir? Hmm? Install like easy package. Word. That's a package to handle packages. Great. That easy packages also allows you to put all the packages that you're going to use in the string line by using the command libraries. So the second command basically instructs R to use the following packages: foreign, ggplot2, and read extra. Foreign is a package that basically reads all sorts of data files. Very, very useful. I have it in practically all of my code. ggplot2 creates much better plots than the default in R. Great plots. Great graphs plot 2 is the abbreviation, ggplot2. That's also a cool library to have in Java. And Grid Extra, it's got a lot of things of putting the graphs together. It also kind of handles databases. So we need all three of them to be installed. Great. Click on the install button down there. Start typing first foreign. Find that, download, and put it in your computer. So install. Let's start with foreign. You only need to install it once, unless you're using one of these computers, lab computers that get wiped every now and then. So we got foreign. Let's also install ggplot2. It reads data in any sort of format. Reads DBFs, Excels, JSON files, you name it. Then finally, let me use Grid Extra. Grid Extra. I'm not using Grid Extra for this one, but I am using foreign. Still, I'm going to be using them for the other ones, so might as well install them now. Okay, so we've installed them, but unless we run the two first lines, R is not going to be using them. So, two processes. You install them once and now they're there, but then in your script, in your code, you need to tell R to include those packages. To do that, run these first two lines. To do it, select them. Do you see that little button that says run up there? Boom. And it now runs them. So basically what this one do is it enabled packages easy package, foreign, ggplot, and grid extra. You can also do that by going here to the package tab and scroll up and down and find the one that you want. In this case, maybe I want to find core plot. Click on core plot. It's the same thing as doing libraries core plot, right? Or see, easy packages is now ticked. Look into your thing instead of this. Scroll up and down into this. It's the environment down here that has the packages. You scroll up and down to that, you'll see that most of them are not ticked. So you can either tick them in like that, or you can write it in most places. If you scroll down and go to where it says easy packages, you'll see that after you run these two lines, it means that R knows that you're using easy packages. R knows that you're using ggplot2 and all that.
Could you have included these packages in the libraries?
Libraries is a command that easy packages has. So you first tell it to use easy packages, and then now you have this cool thing of putting all the packages in the string with easy packages. So R by default does not know the command libraries. know the command library, and it's expecting just one thing in there. But imagine if you wanted to put 50 libraries. You have to put 50 lines one under the other. Library this, library this, library this, library this. Instead, you use easy packaging, you just put one word. Libraries and comma, comma, comma. Okay, so in practically all situations, you're probably going to be using a library. But on the other way around, if you want to do something, in practically all cases, somebody has created a library for that. Right? Just download, install, and learn the syntax of that library. Okay, so right now, in that folder that you have, in that script that you have, put comments right next to these two lines. And to put comments into R, you just put a little pound sign, and then everything that you put after that is not interpreted. So put a little pound key or sign or whatever you call it, and just type, I don't know, library easy packages makes easy packages load. Or whatever you want to put. Instructs R to load library easy packages. Okay, just a little comment. This is what I'm going to be asking you to do. Right? Put comments in the code in the beginning. I'm not going to ask you to generate new code in the beginning. I'm just going to ask you to put comments in the code. When you understand what it does, put that in there. Second line, this one instructs R to load the libraries named here. And you can even say this is a command of the library easy packages. You can even put whole lines of commands by doing whole lines of comments by just putting a little pound key. The moment that you put pound key, disregards everything after that. So you can only install, you can only use libraries. You can only use libraries if you have installed them all. So if you get an error, make sure you install the library first. Okay? If you want that to be a comment, yes. So R is line interpreter. So it looks at this line and says, is this code or is this comment? The moment you move down, you're in a different line and it's going to do the same check. So you can't just put comment and then keep on writing comments. It's going to be line by line. I also like to do this thing. I like to break my code into pieces by doing these, fancy little things here. So the first part is reading libraries. Maybe you want to do that, maybe you don't. I just think it's cool. So I have natural breaks of my code into little pieces. And a cool way to do it is just put a little pound key and some qualities. Make sure that it works. All right. Always a preamble is needed. Okay? As I said now, notice that the 4 files that we want to read are all DBF files. So we're going to instruct R to read all of them one by one and save them. So the next part of the code basically reads those files. But we need to tell it which directory to work in. And now the put everything in one folder is going to come in handy. Instead of going in there, for those of you that have taken SAS, for example, you had to go in and say, look for the date in this directory, and you put the whole thing. Don't do that anymore. Click on Session. Do you see that button up there? Session. And then you can immediately set your working directory. to source file location. So then now R is going to look for the data in the same folder as this code. Done. Okay? Speeds things up a lot. Once again, session, set working directory to source file location. As a matter of fact, put this as a comment up here. Session, set working directory, source file location. What it does is it instructs R to find the data in the same folder as the R script. Okay. By the way, you don't have to use the same stuff that I put over there. Put your own comments. Agreed? By the way, I didn't want to say this out loud. But that guy right there, Alex, he's my TA for this semester's stats class. So he's also an expert in R. So if you got any questions, ask him. Thank you. Just volunteer to be partially TA for the first part of the class. Thank you. Very generous. No, really, if you got any questions, Alex will know. You know, I did stats. You did stats. All right. So put some comments down. Figure out what they do. All right. Finally, time for me to do some real coding stuff. The next line, line number 7 in mine, but the one that starts with temp in yours. What it does is basically creates a list of files called temp by looking into the folder that you're working and finding all the files that end with dbf. So it says, list all the files with the following pattern. I don't know how they start, asterisk, but they should end as .dbf. Does that make sense? So it basically looks into the folder that you're working right now, and it finds all the files that start with whatever you want, but end with dbf. And just keeps the name of that. When you run it, so select this line and run it, and as you see now, on the environment, see something that popped up in the environment? Yes, no, maybe? Everybody? You see this little thing that popped up there? You getting this? Select that line. Form 10. Form dbf. Yeah, that would be a little bit tricky. Now, if it ends as 2015.dbf, then yes, put asterisk 2015.dbf. It will just find that.
Okay. And then the same if they're like that underscore.
No, so the asterisk says anything, and then 2015.dbf. Okay? As a matter of fact, try that. Do that update over there. Instead of just asterisk dbf, just put asterisk 2015 dbf. Oh, just leave it like that. Just put 2015.
Well.
Okay? Alright, so it just finds all the files in that folder that end with .dbf. So you have 4 of them, you give you 4. Now, That is now saved as a list. That list is called temp. If you want to see that list, you can just type in the console, for example, its name. So you can put temp. And click on it. And here are the 4 names of the files it found in there. Okay? So the line here says, find the list and save it as temp. Okay? But that just scraped the names. It did not really read the files. That is done by the line directly underneath. The my files equals lapply temp read.dbf. So the command to read a database frame is called read.dbf. But instead of doing read.dbf corn 2015 dbf and then read.dbf corn 2017.dbf and then read.dbf, so instead of writing it 4 times, 1 for each, this nifty command says do the read.dbf in all the values that you see in the vector temp. So we scraped the names and then we said do dbf read in all these names. So R is going to go and just read all of them. Where is it going to save them? It's going to save them into this big list of files that I just named my files. Agreed? So this lapply idea is fantastic. It does the thing that you would do over and over again. It just condenses it and does it in an automatic fashion. So let's grab this one line and run it. It's going to take a little while. And there's a new element that popped up in the environment over there. And it gives you a description. My files is a large list. And if you click on it here, you can see that it has 4 things in this big list. And you can even click on each of these and it tells you more information about it. So my files 1 is a big data frame, it's a big matrix if you'd like, it's a big Excel sheet that has all this information. All right? But see, I actually want to view this thing. I really want to see this thing. Okay. Remember, all of them are under the umbrella my files. If you want to see the first one, you just want to put my files bracket bracket 1. All right, so put my files bracket bracket 1. And down here in the console, you get an idea of what is there. Okay, it's got yield, it's got flow, it's got adjustment, duration, distance, width, area, elevation, date. And all sorts of things. Yes. Okay. Did you run the first one to get 4 in each plot? Because I'm using 4 in each. So just grab this in the next one. Run them one by one. Yeah, run the first one, and run the second one. Pouring, so the read.dbf is a command that pouring is. Now run it. You also need to run that part, and then run my files. Alright. So if you just say my files 1.1, it pops up here. It's huge, right? That's not a good way to do it. What you should do is say capital V view my files 1.1. And the moment that you do this, you see it in here. All right, so capital V view my files bracket bracket 1. the bracket is because this is a big list of things. And lists in R use double brackets for 1, 2, 3, 4, 5, 10. Okay? Vectors use just one bracket. Data frames use a bracket, but it's two things. Tensor has three things. The moment that you do data frame is just a bracket, but has two values. Because this is not a vector, it's a list of things. A list could contain data frames. Double bracket with lists. The moment that you put capital view my files one, you get the same thing, but you just get it in here and it looks better, right? You can see what this one is. One by one. Right? All right, folks. So that's how we do it in RStudio. Because as you notice, if you try to view it in the console, it doesn't look very nice. But if you capital view it, you view it like this. Great. Now, so in this view my files, please go ahead and put some comments right next to it. Okay, so this view business lets you see, you can see what is in the first element of the list in a nice way. Right? If you were to just type my files one, you can still see it, but it doesn't look right. If you do capital view, and it looks better. And this part was basically reading my data. Again, if you like this process of breaking up the code, great. If not, don't even bother. Fantastic. So, if you look now at this temp, okay, this was the list of the different database files in there, right? So we had corn 2015, corn 2017, and so on and so forth. But there's that annoying .dbf at the end, right? So what I want to do now is I want to somehow keep the name, but drop the .dbf from it and attach that into the files. Okay? Why do you want to do that? Well, that will keep track of which one are we looking at right now, because now you're looking at my files one. Okay, which one was that? Was that corn? Was that corn 2015 or 17? Was that wheat? So I'm going to try to somehow put that inside the command as well. So the next part of the code, what it does is it basically reads those names and chops off the dbf from it to just have what it was. And to do that, you create a new empty list of names, which are called temp new. So the moment that you put C in a bracket, it creates an empty list of things. As a matter of fact, an empty vector. and then your first for loop in R. What this one does is it goes through the length of temp, so it starts from 1 and goes all the way to the end. Temp was the one that had the names with the dbf, and goes to the first one, the temp 1. And it splits that name by dots, right? Because remember how it was corn underscore 2015 dot dbf. So it says string split that where the dot is. And keep the first part, and that is abbreviated with bracket, bracket 1, bracket 1. So take whatever the name is, split it where the dots are, and keep the first part. Append that into temp new. Make sure you do that with all 4. So if you grab this whole piece of the code, these 4 lines that start with temp new and end with a bracket, and you run it, now you see you have a new vector over there called temp new. And if you look at that temp new, it's the list of the things we had before, but it doesn't have that .dbf. Okay? So once again, what this one did is create an empty vector, then read the other vector one by one, take the first argument, split it where the dot was, and keep the first one. Take the second argument, split it where the dot was, and keep the first one. So, string split, very useful piece of code. If you have the naming protocol that we discussed last time, and you string split by underscores, you can break that name into its components, right? It's very useful to know about string split. Okay, now I want to work with each of the 4 data sets separately. So now I'm going to give them names. The next part of the code creates what's the default way of storing data in R, and that is called the data frame. If you're worried about the name, it's just framing the data in a matrix format, data frame. And so basically I just give them names with the next 4 commands. I say the first one, df1, is my files bracket bracket 1. df2, my files 2. df3, my files 3. df4, my files 4. So I create 4 data frames, 1 for each crop and year. Run the next 4 lines of code together, please. So this part basically creates data frames for each crop and each year. And those data frames popped up in the environment, top right corner. Do you see them there? There should be a df1, df2, df3, and so on, right? If you run these 4 lines of code, now you have another 4 elements up there. Click on the click on top of them, and again. So you can either type capital view df1 and see it, or go up over there, click on top of that, So instead of typing view, you can also click there. Click on the data frame that you want to see. And here it is. So RStudio has all these cool built-in click, do whatever, and then shortcuts. All right. So that is how the data looks like for, I think this was Corn 2015. These are the variables that it had in there. The yield, flow, adjustment, duration, distance, width, area, elevation, date, grower's name, field name, and crop name. Okay. All right. So remember last time that I told you, if you're looking at a DBF file, it's probably larger than it should be because it has all this metadata crap attached to it. If you just need the information, basically the table of values, the best way to do it is to save it as a .csv. Okay? Save it as a C, comma separated values. So the next part of the code does the opposite of read. It does a write. So what we're going to do is we're going to save those 4 data frames using their names, but now as CSV files. And I could have done that with an lapply, but I'm doing it now with this little loop. It's the same thing. I'm just trying to teach you different stuff. So the next part of the code is going to take those 4 big tables and write them down into CSV files that we can open up with anything else. Before we do that though, this is again good practice. Go to the folder where you have everything saved and create a subfolder in it. Name it processed. Go back to your desktop or wherever you see things. Just create a new folder. Give it a good name. Good practices. There should be a folder where you keep your process. There should be a folder called graphs. Because you can generate a ton of graphs and part of the whole thing. There should be another folder that says results. You can do such an analysis. So, I even do another folder where I keep all my data. Create a subfolder over there that's called process. And everything that we do in the analysis will be saved in that one. Read, go back. The next line of code, the next 3 lines of code are going to write inside that process. Okay? If you don't put anything and you just do write.csv, it writes everything in the folder you're working. So imagine what's going to happen. You're going to have a bunch of raw data that we got, and you have a bunch of analyzed data in there, you have a bunch of graphs, and you start putting them on the same page, it's flooded very fast. So keep things tight. All right. Next 3 lines of code, let's grab them and run them. And what these do is, again, they go through all the 4 folders, all the 4 elements that you have in your temp. They write the CSV. Write.csv is the command. My files 1, my files 2, my files 3, my files 4. It's going to do that until it exhausts the whole list. And then it's going to save them in, see how you move to a subfolder? You do a // in the name of the subfolder and a slash. So this one says, I mean, if you don't put this part, it's just going to save it where it is. If you put this part, it just moves everything into the subfolder that you see. If that subfolder is not there, it's going to give you an error. That's why you create the subfolder earlier. And then, since I want them to have these new names, all right, I got to say use this piece which is fixed, but also use this piece which is variable. To do that, the command is paste 0. So paste 0 basically. You can put as much as you want fixed. So this part is fixed for all of the names. And then part of the name comes from variables. here, this was going to go through temp new. So it's going to say corn 2015, corn 2017, soybeans, wheat. So it's going to be a different name based on which one you're using every time. Okay? So base 0 allows you in R to have fixed plus value. Let's run these. Okay. And now, if you go back to your folder that you're creating things, you will notice that there's stuff inside the process. Go back there, check it out. So first things first, you effectively generate a couple of things. Let's go back to the code. You got no. Grab the number line. Oh. Right, so the for loop, it starts with the bracket. It's still, no, it's, now it's going to stop. Go back to the code. So you have effectively translated for dot use. So you can use R to convert formats. Now you can open these files with Excel if you really, really like Excel. So there. Very good. Now, what do I want to do? Okay, what I want to do now is I want to combine these 4 files into a big one. Okay, one after the other. It's actually quite simple. The command is rbind. Rbind is row bind. Basically takes the first one and attaches the second one on the bottom, and then to that attach the third, and to that attach the fourth. So that's how I do them here. So I name this new set combine, and I start with rbind df1 with df2. So let's grab this line, skip one line and grab this one. And if you try to run it, it gives you an error message. Right? Let's figure out what this error message says. It says that they have different number of columns. Okay, let's get to the bottom of this. Data frame 1 has actually 12 variables. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12 variables. Okay? Data frame 2 has 11 variables. There's a discrepancy. They stopped measuring something after 2015. So when you're doing rbind, it says, okay, this matrix and this matrix, they don't match up. As a matter of fact, df1 had the extra thing that was date, I guess, or something. Yeah, date. Date was something that was measured in the first time, but never again. Everything else matches up, and they have the exact same names. So here's a quick way to remove a column. Go to df1, data frame 1, and data frames are rows, comma, columns in little brackets. So this one says, go to df1, take all the rows, because we didn't put everything in there, and subtract column 9. Okay? What to do with that? Well, write it on top of df1. So it says create the new df1 by taking the old df1, keeping all the rows, and removing the 9th column. And you can see why this is very useful, right? You can just move columns around, or you can keep whatever columns you want. You can keep whatever rows you want as well. That would solve the little problem that we had in the previous class that we couldn't select that one row. I could go over there and just say keep row 53 in all the columns. That would have been written by doing something like df1 bracket 53 comma empty close bracket. So that would have chosen only the 53rd row and all the columns. The moment that you put minus, R knows to remove that. So let's run that line first. Right. Suppose that you wanted to remove 9 and 3. You would put C parentheses minus 3 comma minus 9. C for vector. So I'm not removing just one thing, the minus 9. I'm removing a vector of things. I'm removing minus 3, minus 9, minus 5, and so on. Inside here, C, instead of minus 9, you would put C, parentheses, minus 3, minus 9, minus 5. So there you go. I'm gonna do a here. Why talk about it? Let's do something like test equals df1 okay. This way I'm creating a new data frame which I'm going to call test by taking data frame 1 and removing columns 3, 4, and 9. Right? So empty for keep all the rows, and for the columns, since you're going to remove multiple ones, you put them in the C command. The C command is basically do this to all these things in this vector. Run this one, and as you're going to see now, we have this new test data frame, which has only that many variables, 9 variables, because we removed a bunch of them. We removed the 3rd, 6th, and 9th column from df. Got it? Okay, folks. Keep the questions rolling just like that. What if we want to do this? What if we want to do that? And try it out as well. All right. Now, in order for you guys to drop the 9th column, as I said, use this line, run it, and as you can see now, df1 also has 11 variables, and you can now start combining. Okay? So combine df1 with df2. Run the next line. And so now, how do we put df3 on top of that? Well, you are bind the combine with df3. And where did you put that? You put it on combine as well. This is a little bit of the things that you do first in one language, and then they pop up in every language. In computer science, you can create a variable, and when you append or do something on that variable, you can save on top of it.
I accidentally removed the 9th column. I ran that like 3 times.
Okay, so then start again from df1 equals myfile1.
This is the wrong type.
No, just when you give the name, just run this. df1 So that's the problem if you append on the same thing. If you want to avoid that stuff, you do things like df1 new or df1 extra. Or df1
Yeah, I already ran this code first. And then
it could be the case that the variable names are different. Let's find that out. I've actually didn't run it yesterday. Okay. And then let's run this thing. Aha, sweet. I didn't know that was the case. All right, so what's the case here? What's going on here? Now we're trying to combine the 3rd data frame with the other 2. Let's go ahead and check the names here. Here's the problem. The third one actually has yield, flow, adjustment, duration, distance, width, area, date. It shouldn't have date. Grower's name, field name, and crop name. So actually this one does have 11 variables, but it has date and it's missing something else. So now you gotta go and figure out which one is it missing and which one does it have extra. DF3. Yep, so DF3 does not have elevation, but it has date. Crap, what do we do now? Right. What we're going to do is we're going to remove date from DF3, but we'll have to go ahead and remove elevation from the other ones as well. Go ahead and do that. All right. The problem was now things don't match. Right? Why? Because DF3 doesn't have elevation when the other ones do. And if we're trying to combine them, they need to have the exact same information. So go ahead and do the trick that we did with DF1. Subtract elevation from DF1. Okay, but how do we find which column that is? You do. Find elevation. So I do it. And basically, that's the hard part. The analysis at the end of this, figuring out these things is what a data analyst does. And I'm putting you into this example. You send that data set to me and say, combine these things. Turn back to you and say, not. You need to know why. It can only be combined if you kept the same information every year. Forgot 1 year to put elevation, let's use things up for all years. Right. Now you need to remove the elevation. Where's that elevation? Now. Both elevation and A. Sorry, both elevation and A. Okay? You can do either or. You can remove it first and then remove the new one. Okay, so let's pause here because you see the problems popping up, right? If I remove line number 9, now I have a different numbering of the lines. You gotta worry about those things. If I remove elevation from one, but I don't remove it from the other one, the first two don't bond. Go back up to where you first defined it. df1 equals modifiers 1, 2, 3. Start from that. Redo that piece of code. Look at df1. Remove elevation and date. Okay? So update your code. Go all the way up to where it says you need to remove elevation. No. So you need to remove from everything elevation and date.
We put I have the same column that we have
Because they're not the same column. One had date, the other one had elevation. It's still the same number of columns.
They are in different, for example, one is column R and the other is column P.
That doesn't matter. So R is going to find the right one. If this is named elevation, column number 4, this is named elevation, column number 3. The problem is, this data set, there's no column elevation, there's no column date. This data set, there's no column date, there's no column elevation. So in terms of how many they are, they match. That is bit information. So hard to not run them together. The only thing a data analyst can do, remove these columns. So don't nag when I come back and say, there's no elevation in this data set. You say, well, no, there's no elevation for 2015, 16, and 17. Yeah, but 16, 17 for 2015 for core. And what I had to remove it, otherwise you couldn't combine. Yes, you need things about this, you don't know that we exist. And in order to actually do combinations, big data, as they say, you need to conform. If you don't conform, the only thing I can do is remove that information. Or I could create an empty column called elevation. Either or. I can't invent new numbers. And right. If I remove one variable from here, it's still not going to matter. You need to remove one variable from here, one, two variables from here, two, one variable from here, and so on. So there are only 10 common variables. First, you remove it one by one, because that's something that cannot be handled by a command. Why? Why it cannot be automated? Because the first thing that wrote down information did not do it right. Okay? So then you need eyes. That made the process much harder. Okay? That's why I'm going back and saying, follow the protocols. Make sure you did things right. If you did things right, it's just a little. If you did things wrong, we're going to be typing df minus 8, df minus 9, and all like that. Ultimately, all of them should have 10 common values. Does it work now?
Yeah, I just did. Oh, okay.
All right, we spent maybe 10 minutes fixing this.
I don't know if I may have done it.
First one, you need to do both.
Oh, okay.
If you do it like that, there's no range.
So it's just component.
Remove this one. Yeah. C minus 8 minus 9. In order for that to work, I think you start from from either save as we say, and then just put over there comma, C, parentheses, minus 8 minus 9.
Still telling me.
Oh, there it is.
I don't know if it may be because it's not the same order. But now
I think I know it's.
elevation as well.
Oh, okay.
Because I
Provision's still there.
I mean, it's still there, but I set it. From 8 to 9.
This should be C, comma,
Oh, I see, I see, I see. Okay.
C prime, comma.
Oh, I run using them.
Rows and columns.
Do I run the
All rows. Comma, nothing function over yeah, comma minus 8, comma minus 8,
Okay.
comma minus 8.
Wasn't that the code that I copied over?
I went to the bottom.
Oh, but I just meant.
Okay. That's what I thought. Okay.
All those.
Where did all the commas go then?
Now when you run it,
Yeah, it's done.
now, notice how much time is took for this. It is not the analyst's fault that we cannot turn back your work order within the year. Fix your stuff. I'm trying to combine things over there that don't match. I don't know what I'm looking at. You do. But I gave you the elevation. Did you do that for every year? Are you spelling the word elevation the same way? That would affect it too, right? If the names don't match precisely, computers are not smart. They will not see that your elevation written with a V is the same thing as the elevation written with a V. Right? You would still say different names. Okay? And it takes a long time to fix these things. We also lost information now. We don't have the elevation nor the date. You didn't keep track of it in 1 week. If you really want to do a combination of these things, you need to be super careful about it. All right. So the new code now should look like this, folks. We go back here. And we fix all of them. So df1 should be c minus 8, comma minus 9. And as you can see, this has to be hard-coded, as we say. There's no way that we can just do it just like that. I mean, I can just copy-paste a bunch of things, but that's just about it. Huh? All right, now that we're running all of these, we have 10 common variables. And now finally we can run the combined stuff one by one and get ourselves a big table that has about 100,000 entries and has all of them, but we lost the dates. Bummer. And we lost the elevation. Double bummer. Because one of the things that I was asked to do is find the correlation between building the elevation. That's what I cannot do right now. So then you turn that back and say, look, I can only do elevation when these things do for that, for there. So I can't really give you a combined set for everything you do for that, but you do. And the question is then, can you not extrapolate for everything else? It's not the same data function as another. Because the combined would never start in the same place. This year we started doing this way, and then there's no way for you to figure out how to do all these things unless you keep track of them going through. That's exactly what I told the guy that I've never heard from him.
So this is an actual data set?
This is an actual data set, yes sir.
And they want you to compare yield to elevation?
And various years, various locations, various, this is a piece of a much bigger data set. I have 65 locations. I had more data in it as well, things like soil type, locations, just soil type. I don't know the details of how it works. If you have to do this analysis, soil type, location, water, but then the questions that I was getting back was like, can you do a method that does that? I'm like, yeah, let's try it. And then I got into this kind of thing going around getting higher than these things. So I actually had to tell the other person, look, it's too much to look at you as if I'm talking to you. How much time do you give this kind of thing? You're talking about one clarification for you. So, going back to one of the objectives of this class, make sure you can communicate to the analyst whenever questions are all. Make sure you understand what kind of problems they pop up and do the data collection. Still, this is a big combined data set now. I can do all sorts of analysis between those. Tens and tens. Histograms, ANOVAs, you name it, anything you want. All right. By the way, 85,000 data points is a hard max for SCADA. And normal SCADA, the program cannot handle more than that unless you have a SCADA. We are already past SCADA. SAS doesn't have any problems with that. And, okay, if you pay a little bit extra SCADA, you don't have problems. But the basic undergraduate student cheap 1 year SCADA is 5,000 plus. Okay. R is the future. Great. Any questions, any problems with this? Fantastic. All right. That's all I wanted to tell you today. When we come back on Monday, we're going to discuss a little bit homework 2. And I mean, you could start this one, but since we didn't cover how to grade, you're missing some information. I'd rather we do that first. So next Monday, we're going to continue on playing around with R, learning a bunch of things, and we will also give you the homework. There's not going to be a class next Tuesday. We have the Digital Ag Day. It happens in Alexandria. I'm going to be giving a talk over there. Some of the students that took the class last semester are presenting posters. And just to give you an idea of what's up, we have about 60 vendors that are involved in anything that has to do with precision ag, big data, analytics, drones, you name it, that are going to be there. And so these students are going to get a chance to present their work, and I'm very confident we'll have a bunch of internships over the summer. So that's probably not going to happen with you guys this semester, but why not next year? If you're looking for a sponsorship, if you're looking for some extra money, that's a good way of going about doing it. Okay? And I was already told by one of the vendors that they want to hire people that have this dual ability. They have their own background, agronomy, whatever, but they also know computers. He was specifically saying that up until this past summer, they were hiring people from various fields. Starting from this summer, they're going to just stop doing that and only hire people that know digital ag. Like, you have to know Python. You have to know databases. And from the way that he was describing it, apparently, these people exist now. And they're going to be the first choices. So there are people out there that have the background that you have in your specific field and know about data analytics. So there are jobs out there just gearing towards these folks. So anyway, that's why we won't have a class next Thursday. Let's save everything here. And notice that when you save, it tells you, do you want to save the environment? Click yes on that. That basically saves all the variables that you just created. It also saves your selection of libraries, so you don't have to re-enable them next time you open it up. And it also saves anything that is temporarily stored in memory. Agreed? So click save and get out of there. All right. So since we don't have a homework for next week, I'm going to give you a verbal one. Go ahead and check out the art trinkets. Make sure that you understand fully what the code did today in class. Get some of those art trinkets that need work and start adding comments to it. Please download it first onto your own computers. Do not try to add stuff onto that repository up there. I don't remember if the link allows you to, so let's not jeopardize that. Just download whatever you want, create your new folder. Good practice always to do that, and start playing around. Okay? So, whatever you want to say. Yes, sir. All right. So I will see you Monday.
So whatever you do, that's yeah, that's my point. I really can't make much. Yeah.
See. So just classic stuff. Save as. Or there's this save button. You can even try to close it, and you can try to save. That just saves the data. Try to close it. Close it. It says, do you want to save everything? Just click save, and it saves everything that's in our data. That's what you try to do. Close it. You want to save it. So this one, the next time that you open up the script, everything's going to be pre-populated. You're going to have the libraries there, you're going to have the data that you create, the temporary variables that you create, you have to remove on the beginning. Now, another thing that I would like you to get into the habit of, go to that multi-reads.r that you see and use our naming protocol. Your own initials in the beginning, underscore multi-reads, underscore 1 is the first time you follow. Okay? Version control. Get into the habit of that. Right? .r is right. So this is, you created this, and then you want to use it. And then if you want to more class. So this saves the workspace. All variables are saved, libraries are saved, group events are saved. Correct. Correct. R is running in the back. Pascal was a fine line. I wrote Pascal good. I thought Pascal was good, and then I was looking before the other. Oh, this is much better. And then someone said, but this is what we had in Greece back in 1998.
That's not old enough.
That's how old I am too. But then in 2003, I guess, is where I first learned MATLAB.
Yeah.
It was literally like, geez, you can do all these things in MATLAB? And then 2006 is I learned about R. 2008, or no, 2011 is where I picked up Python. 2013, well, no, 2011 I picked up C++. 2013 is where I picked up Python. But again, folks, how many of you already speak computer language? So the moment that you speak R, then you speak Python in a couple of weeks. Take a course, an online course, and you can speak Java in a couple of weeks. It's the first language that's hard. The rest is going to be like, oh yeah, it's the same code but different syntax. Got it? I know that you write loops somehow. Let's Google that one. That's how you write loops. Okay. The first loop in whatever language, all the loops are the same.